Welcome back, everyone. So far we have studied functions that can do lots of different things in terms of growing at a constant rate or declining at a constant rate, or growing or declining at a constant percentage rate, and maybe even growing for a while and declining for a while, like a power function, or declining and then growing. What we don't have is any sort of function to model things that just repeat themselves over and over and over forever, like many natural phenomena that we experience in the real world. So that's what we need. We need functions to model cyclic or repetitive phenomena. And as you probably can guess, these are going to be our trigonometric functions. There are two different shapes that we define our trigonometric functions on. I first learned them on triangles. That's where the name trigonometry comes from, measuring on trigons. We don't say trigons very often. We say octagon and hexagon and pentagon, but we stopped saying trigon and now we say triangle. But trigon and triangle mean the same thing, a three-sided figure. And you can measure things on triangles, but the trouble is that if we want something to repeat itself forever and ever and ever, we'd like the domain of that to be all real numbers. And the trouble on a triangle is that if you're measuring in, say, degrees, the smallest angle you can get is 0, and the biggest angle you can get is 180 degrees. And so that runs into some trouble. So instead, we define our trig functions on the unit circle. So unit in math means 1. So a unit circle has a radius of 1. So that's the point 0, 1 up there. And this point over here is the point 1, 0. And a unit vector in math is a vector that has length 1. Unit always means 1. So we start here. This is our angle 0. And we go at a certain angle. And it's sort of traditional to use, at least when we're starting off, Greek letters for angles. So this is the Greek letter theta. You can use whatever letter you like. I would suggest not using x and y, because we're going to use that for something else in a second. So we start here at an angle, at the angle 0. And we go to some other angle. And at this point, we are at the point x, y. And one of these coordinates, x or y, is going to be what we call sine of that angle. And the other is going to be cosine of that angle. So that's going to be our definition. Sine of theta is one of these coordinates. And if you've studied trig before, ask yourself right now what letter I should be writing in there. And I hope you will say that sine is the y coordinate. So we start off, sine of 0 is 0, because my y coordinate here is 0. And we define cosine of theta to be the x coordinate at that same angle on the unit circle. So we can talk about how we should measure angles. We're going to put that off for 1 second and first talk about the graphs of these functions. So one of these functions here is sine of theta, and the other one is cosine of theta. So let's see if we can figure out which is which. If we do cosine, we said cosine is the x coordinate. So when I start right here, my x coordinate is 1. And as the angle theta gets bigger, the x coordinate gets smaller, meaning cosine at angle 0, cosine of 0 should be 1. And then it should decline. And so which one of these does that? When theta is 0, meaning when you're right on this axis, this one is not at a y value of 1, but this one is at a y value of 1. So this is our graph of cosine theta. At an angle of 0, cosine is 1. And then as we go around the circle, the x value gets smaller and smaller. Now the x value is 0. Then the x value becomes negative, gets all the way down to -1. And then comes back around until the x value is back at 1. So that's telling us that the highest point on this graph is 1, and the lowest point on this graph is -1. And by the time we've gotten over to here, we've gone 1 full time around the circle. And the nice thing about the unit circle that we can't do on a triangle is I can go backwards as well. I can start here and go into negative thetas, and then the cosine graph goes like this. I'm intentionally not writing any units on these yet because we still have to decide how to measure our angles. As you can probably guess, this is the graph of sine of theta, because if sine is the y coordinate, we start off with a y coordinate of 0. And as the angle gets bigger, the y coordinate also gets bigger until the y coordinate gets to a maximum of 1. So the y coordinate also gets to a maximum of 1. And then as I keep going around the angle, by the time I'm down to here, the y coordinate is at -1. So my graph here reaches a low value of -1. And as we've said, this is the graph of sine of theta. Normally at this point, when this room is full of 100 people or so, I like to ask, are these shapes semicircles? And usually about half of the people will say yes, and about half the people will say no. So decide for yourselves at home which half you're in. Do you think that this is a semicircle? And is this a semicircle? We'll come back to that after we decide about how we measure these angles here. All right, so how do we measure angles? There are lots of different ways. One full time around the unit circle could be an angle of 360. I've left these blank so you can fill them in for yourselves. But 360 degrees. That's one way of measuring it. That comes from ancient Babylonian Sumerian times when they used a base 60 number system. We talked about a base 10 number system. Base 10 is nice. It has two factors of 2 and 5. Base 60, do you know how many factors there are? There are so many. Base 60 number system is really great to use. It's a shame we don't use it. We use it every once in a while nowadays, right? We use it on clocks, for example. And we use it for this, base 60 there. Shortly after the French Revolution, when they were coming up with the metric system, they decided that there should be 400 gradients in a full circle. That hasn't caught on so much, but it does still survive, apparently, I'm told, in surveying. So when you see somebody out doing land surveying, they measure in gradients. There's 2 pi radians. That's one that we'll talk about in a minute. But you can really use anything you want. They'll all work. Well, you shouldn't choose 0, but we could have 28 Ethans if we felt like it. If your name were Ethan and you wanted to name a measure of unit after yourself, 28 Ethans. That would be great. And then a right angle, instead of being 90 degrees, would be 7 Ethans. Now, 7 doesn't divide itself up so well, so you might not like that. But anyway, you can put whatever your favorite number is here and your name and name it after yourself, and it will work. And they all work. The question is, which one works the best? And there is one that works better than all the others. And the main reason that it works better, we won't be able to say until we get into calculus several weeks from now. Although we do have an applet for you to play with right after this segment that gives you a pre-calculus, some idea about why one of these might be preferred over the others. And in fact, the one that is preferred over all the others is radians. So that is the one that we are going to use. We're going to use radians. So now we can put some points on these here. So one full time around the circle, that's 2 pi. So this also here is 2 pi. And when we've gotten up to the very start there, that's pi over 2. So this is pi over 2 like that. This is negative pi over 2. I'm not going to put all the points on there, but I hope you get the idea. This is pi. And so now, for example, there's actually a couple of reasons why these can't be circles. One is that if you look at the graph carefully, a circle should have a perfectly vertical sort of tangent line here. We haven't talked about tangents yet, but that's another thing. But another thing is that if you believe these are circles, then let's see. The radius of this so-called semicircle, half circle, this radius is 1, right? But if I measure the radius in this direction, I should also get 1, right? So this distance must be the same as this distance. So this distance is 1. This distance is pi over 2. So if 1 equals pi over 2, that means that pi itself must equal 2. And I hope that as soon as you see that, you say, there's no way that's possible. So that's another demonstration of how we see that this is not a circle. So this is our introduction to trig functions. We know what the graph of sine and cosine look like, how they're defined on the unit circle. We have coming up in several weeks a good reason for why, very strong reason for using radians. Now we have this applet for you to play with a little bit to see if you can come up with a non-calculus reason why radians will work better than anything else.